Alright, I went ahead and opened up a new Arduino sketch. To begin with, I'd like to say that if you have not had an introduction to analog components and servos, I highly suggest going back to our videos on those in the course, since it will help you understand this code a lot more and to be able to take more out of it. So the first thing we need to do is include the servo library. So let's go ahead and do a hashtag include, and then servo.h. Alright. Then below this is where we are going to name the servos. So we have 4 different servos, and I'm going to name them S1, S2, S3, and S4. And the bottom one being S1, going all the way to the top of S4 as the gripper. So I'm just going to go ahead and do that with servo S1, servo S2, servo S3, servo S4. All right, next we need to initialize the potentiometer variables, and those are set to the analog ports, so let's go ahead and initialize those. Enter, and I'm going to name these in a similar fashion with P1, P2, P3, and P4, with each one controlling their respective number of servo. So if P1 will control S1, P4 will control S4. I'm going to set that, and I set these in ascending order in plugging in the pins, so that P1 would go to A0, P2 would go to A1, and so on. So just make sure that your potentiometer is plugged into the correct port that you're mentioning here. Then I'm going to initialize P2, A1. Okay, so we've initialized these variables. Now let's go up here and make a little comment that tells anybody reading our code what we just did. So we included servo library and initialized potentiometers. So you can also, in this above void setup, you can declare the value variables for each of the potentiometers, but I'm going to go ahead and save space by just doing that in the void loop function that I'll show you later on. So in the meantime, let's move on to void setup. And in void setup, we first need to set the potentiometer variables to input variables. So let's go ahead and declare pin mode of P1 is input, and the same thing with the other potentiometer variables. Alright, additionally we also need to define which ports the servos are plugged into. So I plugged mine into PWM port 3, 5, 6, and 9 in ascending order based on the servo. So S1 is the lowest, S4 is port 9. Keep in mind which ones yours are plugged into, or else you will get a different result if you plug in the same code that I am without changing the pinout of your servos. So let's go ahead and attach S1, attach that to port 3 for me, S2 dot attach to port 5 for me, S3 dot attach port 6, and 9. Alright, so we have just initialized the potentiometer variables as input variables and attach the servos to their respective ports. Let's go ahead and comment that. Alright, so now that we are done with void setup, let's move on to void loop, and the first thing we need to do is initialize the value variables that we did not initialize up here to conserve space. Instead of having to initialize the value variables and then redefine them down here, we are just going to initialize them down here with no need of redefinition. Let's go ahead and make int v1 is equal to analog read of the potentiometer one. So these are going to be named just as P1 through P4. This is going to be a V1 through V4 corresponding to their numerals. Okay, analog read of P2. Alright, so now that we're done with initializing the value variables, we need to move on to translating them to a position that the servo write function can understand. So the potentiometers read back a value from 0 to 1024, and we need to remap that to a value between 0 and 180 degrees. So we need to redefine each value variable. So I'm going to first redefine v1 is equal to map of previous v1 from 0 to 1024, so the minimum and the maximum of the potentiometer, and I am going to want to change that to a proportional value between 0 and 180 degrees. I'm going to do that for every one of them. Alright, so now that we have redefined the value as a position from 0 to 180 degrees, we can now write that position to the servo. So we do that through our servo write function. I'm going to do s1.write as v1. So they will correspond to their respective potentiometers. So write v2, s3.write v3, s4.write v4. And down below I'm going to have a delay of 10 milliseconds so we have a fast response from the potentiometers. Alright, so keep in mind that the way you have your potentiometer set up, you may want to reverse the direction of the way it is going as you turn the potentiometer to the right. So if you turn the potentiometer clockwise, you may want to reverse the direction that the servo turns. So to do that, all you need to do is go up here. So for my V1, I change to map from 0 to 1024 to map from 180 to 0 instead of 0 to 180. What this does is when the position of the potentiometer is at 0, then it will translate to a position of the servo at 180 instead of at 0 degrees. Similar for the 1024, at the maximum of the potentiometer values, it'll translate to the minimum of the servo values. So it'll reverse the direction that it goes as you turn it clockwise. So I'm also going to do that for my V3 variable, as it is in a similar situation. So let's go ahead and write a comment that describes what we did. So initialize the value of potentiometers and write those values as an angular value to servos. Alright, so now let's go ahead and download that to the Arduino board. Okay, so go ahead and upload that to the Arduino, and you'll notice as you turn different potentiometers, the value of the servo position increases and decreases. Let's test it. A little piece of tape. I'm going to put it over, still getting a little bit new to the controls. I'm going to put it over on the white sheet and then return it. Alright, you just completed the robotic arm project.